Here's a situation that we can address a couple different ways with work in kinetic energy or also with the motion equations in Newton's second law. So we have a Tesla Model 3, curb weight given, traveling at 13.4 meters per second. It accelerates to 24.6 meters per second as it travels 80 meters. We want to calculate the average force applied to the car to result in this acceleration. So let's list out what we know first of all. We know the mass, 1,932 kilograms. We know two different velocities. Initial velocity, 13.4 meters per second. Final velocity, 24.6 meters per second. We know a displacement, which sometimes we use as delta x. In work, we use that as a d. So 80 meters. And then we want to calculate the average force that is applied. Well, looking at these quantities, that's enough to use a motion equation. Then with the mass, we can also use Newton's second law, net force equals mass times acceleration, to get force. But there's another way we can address this problem also. What the car has is kinetic energy, and the kinetic energy is changing. In order to change the joules of kinetic energy, what has to be done to it is work. Those are two different names for the same joules. So we can equate the joules of work that are being done to the joules by which the kinetic energy changes. Work, constant force, because we're calculating the average force, F times D in the same direction. Change in kinetic energy. Kinetic energy is a 1/2 mv squared, so to get the change, that would be the final kinetic energy minus the initial kinetic energy. And now we're ready to plug values in. We want to calculate the force. We already know the displacement, 80 meters, equals 1/2 the mass in kilograms, 1932 kilograms. Final velocity is 24.6. And then minus initial 1/2 times 1932 kilograms. And then the initial velocity was 13.4 meters per second. And then that's squared. So calculate your value here, calculate your value there, subtract them, and then divide by 80 meters. We get an average force value of 5,139.12 newtons. So either method, Newton's second law of motion equations or work equals change in kinetic energy, would be fine. As long as you do the algebra right, you're going to get the same value plus or minus a little bit of rounding. Ponder physics.